For number 47, we're solving an absolute value inequality. Number 47 is a greater than problem. And we had a mnemonic. Greater sounds like great or. We had a little memory device that said whenever you've got two bars in an absolute value equation or an inequality, it means you have to write down two things. In this case, you have to write two inequalities. One, plain and simple, is x plus 4 greater than 2. It's as if you just recopy the problem without the absolute value bars. But then we're going to put this very important word or in. Or is completely different than the word and. And then we'll make a second inequality. We'll say x plus 4. We'll say less than, and then we have to put in negative 2. For your second inequality, guys, two changes. Flip the sign, flip the arrow, always put a negative in. The solving isn't the difficult part. I'm sure you get to here, you could say, well, wow, I'm going to minus a 4 from both sides. I'll have x greater than negative 2. Here, when I subtract a 4, you'd have x less than negative 6. What is your solution? Two inequalities, and you're connecting them with the word or. For number 48, this should seem very familiar because it's what we did just last week. The quadratic formula, something that you will be thankfully given on the actual final exam. You don't have to have it memorized. But look, your A would be 1. Your B is negative 3. Your C will be positive 1. Now, guys, definitely, please store these values. We'll hit 1, hit store, and then hit alpha A. Negative 3, not a minus 3, but a negative 3. Type that in for alpha B. 1, store that for alpha C. Now, guys, when you're solving here, you want to actually get the inside of that quadratic formula first. You want to just find out what b squared minus 4ac really is going to equal. So I'll type in alpha b. You'll have b squared minus 4 alpha a alpha c. Hit enter and you get a very nice answer. I'm saying it's nice because you're not going to have to break down a radical. Look, if you were to put your answer down, it's going to be opposite b. Well, what's the opposite of negative 3? Negative 3 becomes a positive 3. The inside of this square root is simply the number 5. And down below, you just have 2 times 1. You're almost done. Yes, it's 3 plus or minus radical 5 all over 2. But like we've been saying, you would separate this into 2 distinct fractions. That's 3 halves plus radical 5 over 2. That would be your first answer. Second answer would be 3 halves minus radical 5 all over 2. Okay, so you'll have one quadratic formula type of problem to do. Take a look at number 49. Guys, number 49, the range is simply the y values. This is going all the way back to chapter 2, I believe. And, you'll have all these y values. You could write in a little bracket 3, negative 5, 6, negative 8, and 4. If you write that, you're absolutely correct. On the final, though, it's very likely that the answers could occur in increasing order. By the way, the first answer is just as correct, but I don't want kids to hit the panic button and say, well, I've written down my y values and I don't see the answer there. They might just rearrange them, of course. Guys, one more problem and then we're through. Problem number 50, square root of negative 24. You see a negative inside of a radical, take out an I. You'll have I radical 24. Then what? Well, the big question is, could 24 be simplified? And it can. Look at your first prime, look at a 2. 24 divided by 2, you'd get 12. 12 divided by 2, you'd get a 6. Try 2 again, 6 divided by 2 is a 3. So you have 2 times 2 times 2 times 3. Guys, that's honestly how you want to break down that radical. But we're looking for 2 of the same factors. We're looking for doubles of numbers. And I have circled out a 2. Whatever you circle, you pull one of those out. What's left inside? Well, 2 times 3, you'd get a 6. Your final answer is 2i radical 6. And we're done.